Alright, well, just opened up Geogebra here, and I wanted to make a video on how you could use Geogebra to help your kiddos, maybe better understand the addition, elimination method for solving systems of linear equations. So, here we go. This was just, I don't know, couldn't sleep. This sounded like fun. So I figured out how to do it with Geogebra. Anyway, so you got to start by, I don't know, you need a system of equations. So you got to make a couple lines. Instead of putting in like fixed lines, like, you could create a function here like a of x equals 5x plus 6, 5 times x, and the line's going to show up. Well, that's cool, but I can't change that line. It's just fixed. I can't drag it. I can't change where it. Oh, I can't change its slope. I can change its. Let's see if I can change its slope. No, I can't. I can change its y-intercept. Maybe I can change its slope. Doesn't look like it. No. So I can just change its y-intercept. I want to be able to do more than that. I'm going to take this out. Right? Like this line has a point. Sorry, it's got a slope and a y-intercept. So let's move this around a little. Get my grid recentered here. Okay, sorry. So we're going to use this slider thing. Okay, I'm going to create a variable, and this slider allows you to change the value of that variable. So I'm going to call it SL1, slope of line 1, SL1. Let's do it like this, SL1. Okay, so I need two lines, right? Okay, I need a slope of line 1. I need two lines, so I'll have SL1. I'll have y int L1, y-intercept of line 1. Okay, let's move that just a little. Okay, so you got the slope of line 1, you've got the y-intercept of line 1. So now you could build a line from that. You just go to your input and you'd say, we can name it. I'm gonna call it a of x. Okay, well, we'll call it line 1. Line 1 as a function of x equals SL1 times x plus y int L1. So you'll see a line show up, and I can change the y-intercept of that line. If you double click on this slider, you can have more options, like this only goes -5 to 5. But, right, I've built a line that can be modified. So build another line. Well, another line's going to require another slope, another y-intercept. So a couple more sliders. Let's go SL, slope line 2. Okay. Move these guys here. Clean it up a little. Okay. Need another slider for the y-intercept of line 2. Y int L2. So you've got these lines that are going to be able to be modified, right? Because we want to be able to show kids that it works for, any two lines. So I've got line 1 as a function of x. Let's go line 2 parentheses as a function of x is slope line 2 times x plus y-intercept line 2. So I got two lines. Okay, not that impressive yet, but basic idea is you got a system of equations. We gotta have the system before we can talk about solving it. I might need to move this one a little for now. Okay, so you see I've got 2 lines. Now, here's the thing. I can modify each of those lines. Let's say I want to modify this one more. Minimum, let's go -10. Maximum 10. So I'm just adjusting those slider values. Okay. So I'm going to undo something there. It's looking a little funky. Okay. Trying to clean this up. Okay. Alright. Okay. So I've got my 2 lines. They can be modified. Now my third line, right? My third line, really, I want to talk about with kids. Okay, the third line is going to be those 2 lines added together. Well, you know, for kids, what does it mean to add 2 lines together? So, say we open up Word here. So, like, let's say you have like y equals. Let's zoom in. And okay, so you have like y equals 5x plus 6. That was one of your equations. And then you had y equals, I don't know, x minus 1. So you'd say, okay, well, what happens if we add these 2 lines together, right? Well, you get 2y equals 6x plus 5. And you say, okay, kids, now, you know, solve that for, you know, what does that line look like? And most kids will say, okay, well, that's the same as y equals 3x plus 5 halves. Now, the reason I took you through this is, notice how this is y equals 3x plus 5 halves. That last step we all know was dividing by 2 to solve that. Now, you know, what we'd maybe have our kids do at this point is, hey, graph that new line. What do you notice? Well, what kids are going to notice that new line intersects exactly where the last 2 lines intersected. So I guess we could go back here. Right, we want a new line that's these 2 added together. So you're going to make a new function, right? You've got function line 1, you've got function line 2, and we've got this new line that's going to be, you know, basically line 1 plus line 2. And here's what I learned when I started. Let's call new line, I don't know what we want to call it, sum line, not S-O-M-E, S-U-M, sum line as a function of x equals line 1 of x plus line 2 of x. Okay, so here's, watch, I'm going to hit enter, and I don't think it's going to intersect at the right spot. And you're like, what's going on? No, that didn't work. Okay, well, if you just look at the code and you look at what it did, you look in here, look at it, it really did add them together, but it didn't do that whole like add the y coordinates things together. So it just graphed y equals 6x plus 5. It didn't graph that y equals 3x plus 5 halves. So what do we do to both sides at this step? Well, we divided them by 2. So if you go back into Geogebra, so it's, I want to graph some line of x is line 1 of x plus line 2 of x divided by that whole quantity divided by 2. Now we should get a nice intersecting line. But that wasn't enough, right? You really just showed kids, hey, you've got 2 lines. Did you know that you can, if you add those two lines together, you get a third line. And what's special about that third line is the fact that it intersects where your first two did. So a kid says, wow, that sum line, that doesn't look very nice. I mean, I don't understand how that's actually going to help me. Big deal, teacher. Two lines intersect. There's a new one. I think we can clean up that sum line. I think there's a simplify. Yeah, there's a simplify function. Simplify sum line of x. Sum line of x. Okay, so like right here. Well, yeah, big deal. You know, that's not that convenient. You know, it's a new line, but it doesn't help me. And we want to, you know, now talk about, well, yeah, you could add two lines together and you get a new line, but you know what you can also do to a line? Like, you can multiply it by a number and it's still the same line. You know, we go here and we tell a kid, like, you know, how does this line here, how does that compare to, say, the line, I don't know, 6y equals 30x plus 6? How do they compare? Kids should, you know, I guess figure out, well, they're the same line. Oh, that's weird. What about this bottom one here? How does it compare to 6y equals 6x minus 6? Right, we just multiplied everything by 6. 6y equals 6x minus 6. And they say, oh, that's the same. So the idea is, hey, originally we added, let's highlight this thing. Originally we added this line and this line. We got a new one. A new one wasn't that, you know, that helpful. But what if we add, instead, you guys know where I'm going with this, what if we add these two? And this is kind of weird. We'd have to get into some deeper discussions, but if we add these two, you know what? We get a new line. But it's not the same line as if we added those two, which is really weird for kids. But, you know, we can talk about it some, but we can only talk about that one so much. So, hey, you know, you add these two, you get a different line, but it still intersects at the same spot. So what I wanted to do with Geogebra, I'm going to end up deleting this whole sum line thing, is, yeah, I do want to add two lines, right? But I want to be able to adjust. Like in my head, I was thinking, okay, I've got this, like, I don't always want to do, oh, come on, Microsoft Word. I don't always, it's not always necessary or helpful to go line 1 plus line 2, right? That doesn't always yield great things. You know, if we call this first one in yellow up here, if this was our line 1, and this here was our line 2, well, we know line 1 plus line 2, let's move you guys. Line 1, fighting my computer here. Line 1 plus line 2 wasn't that helpful, and we showed that using Geogebra. Moving some stuff. It wasn't, you know, it wasn't that helpful. You did get a new line, and big deal, but it didn't really help me. So what I wanted to be able to do, instead of just going line 1 plus line 2 always, and remember, it was like your new line was line 1 plus line 2 divided by 2. Right, because at this step you had the 2y equals, and you had to divide both sides by 2. What I wanted to do, though, is like, instead we want to go, the code I wanted to go like some number A times line 1 plus some number B times line 2 divided by, instead of divided by 2, this one will be divided by A plus B. And if you don't believe me, like, you know, like say you tried this one, right? What was necessary was, hey, multiply line 2 by 6, okay? So then if you multiplied line 2 by 6, you ended up with this guy right here. So if you added this one here, this one here, you got a new line, right? The equation of that new line was like, you know, 7y equals, and you have like just this whole stuff over here, right? So what'd you do to both sides next? Well, you divided both sides by 7, right? So that's why I divided by A plus B. You know, in this case, we didn't multiply line 1 by anything. A was 1, and B was 6. So 1 plus 6, that gives me my 7 right here. Anyway, so I wanted to be able to not just add line 1 to line 2, but add different multiples of line 1 to different multiples of line 2. So we'll go back to Geogebra. This is where it's actually interesting. I'm going to delete this sum line, right, because I want a different sum line. You're going to need a couple more sliders. I'm going to call this line 1 multiplier. I'll call this line 1 mult. Okay. I'm going to have it go from negative 100 to 100. Okay. Line 1 mult. And we need one more. We need a line 2 mult. Line 2 mult. Same thing. Negative 100 to 100. Okay. Okay. Let's get back to that sum line thing, right? I want to add different variations of line 1 plus line 2. So I'm going to go sum line as a function of x equals, instead of, you know, line 1 of x plus line 2 of x, I'm going to go line 1 mult times line 1 of x, line 1 of x plus line 2 mult times line 2 of x. Now be careful, you're going to have to, your last step is going to be dividing by your line 1 mult plus your line 2 mult. Those are just variables, right? They don't need, you know, they're not as a function of x. So I got this sum line. Now I want to, you know, want to simplify this too, right? Go simplify, simplify. If you hit enter, it'll do it. Sum line of function of x. Okay. Sum line function of x. Okay, to get this new one. So, and you know, don't forget, kids are gonna go like, okay, big deal, dude. Okay, I got the 2 lines. I add them together, and I get this third line. I don't know how that third line's gonna help. And we're pushing towards, hey, you know, what if when you added them together, you got a vertical line or a horizontal line? You know, would that maybe be helpful? So, what you can do here is adjust these sliders, right? So, you know, kids should realize, okay, this line 1 of x and line 2 of x, they're not changing. They're the same 2 lines that intersect. I'm just creating a new line, right, that intersects at the same spot. The kid says, well, Okay. Now you're adding different variations of the lines together. So if a kid just keeps watching this and you say, you think that's going to help you? You know, watch how I adjust this. Do you think that's going to help you? You got that undefined, right? Can we get it? Undefined. Dang, that's weird. It went undefined when the line 1 multiplier was 6, the line 2 multiplier was -6. Oh, that's kind of weird. Maybe you'd explore that later, right? Because I don't think a kid's going to see that when it says undefined and go, oh, that's really helpful. Instead, what if you got him to that? If you got him to that, when that line turns horizontal. That's what I was thinking. Okay, so I'm going to adjust these sliders until that line goes horizontal. And you can kind of play with them. Okay. So, okay, keep going. Keep going. So this is what I do with what I think I'd do with kids. Oh, that line's almost horizontal. Okay, now I'll modify this one. Now, how do I tell when the line's horizontal? Well, okay, guys, what does the equation of a line look like when it's horizontal? It's just y equals a constant. So I'm trying to turn this into f of x equals just some number right here. Okay, so we're trying to make that line horizontal. You know, we thought when it's vertical, it certainly is helpful. Just this Geogebra doesn't have the ability to tell us the equation of that vertical line, because it'd only tell us, you know, about functions. So anyway, so that kind of limits us to trying to make this thing horizontal. So keep sliding this. What about if I adjust this one? Okay. Having trouble. What if I do this one? Okay. How do we make it horizontal? I'm going to have to adjust the increments, right? What I did in the beginning was this line 1. Let's make line 1 a little cleaner. Let's say line 1's slope of line 1 was like, you know, negative. If I can just type a number in here. We'll just make an integer. Oops. Still learning how to use GeoGebra. Okay, slope of line 1. Maybe we can come over here. Slope of line 1 is -2. Done. Okay, and let's go y-intercept of line 1. We'll make it a nice clean number too. We'll call it, you know, 4. Y in line 1 is, we can go 3. Okay, so this is going to clean this up. So the goal was we're trying to get this thing to go horizontal. And obviously we'd have to talk with students. Why would I want to do that? Why would that help me? So I'm adding 2 lines together, but different combinations of those 2 lines. So that's almost horizontal. Okay, I'll adjust this one a little. Got it. 6/5. Okay, so alright kids. So you've got 2 lines. Yes. They intersect? You added them together. Yeah, sort of. I added variations of the lines together. If you do 4 times the first line plus 8 times the second line, you get a new line. That new line is, you know, f of x equals 6/5, y equals 6/5. Okay. Now the goal was to figure out where those 2 lines intersected. So does that new line tell you anything about that intersection point? Yeah. The y values along that new horizontal line, they're all the same. They're all 6/5. Oh. So where those lines intersect, what's the y value? 6/5. Okay, so now we know where to go from there, right? If we know the y value, we can just go to either equation, you know, negative 2x plus 3 or x plus 0.3. If you set y equal to 6/5 and solve for x, right, now it's just turned into algebra, you'll have the x value also where they intersect. So that's, you know, plenty of videos on that, right? But hey, I think that would help kids. I don't know, I might even take them through, like, hey, here's what I was thinking in Geogebra, and or give them some instructions on how could you try to show this. Might be kind of fun. So recap, I built 2 lines. I was able to modify those 2 lines with these sliders I built. You defined line 1. You know, line 1 is this variable SL1 times x plus y-intercept of line 1. Those variables, before I wrote this equation, I had to set up the sliders, and that's just up here. So, you know, now do it with a different problem, right? You can just, we'll modify the lines. Like, so line 1, which one's line 1? Line 1, I probably should have. Okay, line 1 is in blue. 7. Okay, line 2, I'll put that one in red or something. Color is red, or pink or something. There we go. Oops. I wanted the line thickness to be 7. Style 7. Okay, so you adjust the lines, right? Slope of line 1, we can have it be show name and value slider increment. We can just have it go by. Let's have it go by. You have it go by ones or something. I go 0.1, I guess. Let's try 1. Okay, you got 2 lines, so I'm changing the blue line. What if that's my blue line? Let's move it down a little. Okay, there's my blue line, and let's have them intersect in quadrant 4. Okay, cool. So you got, hey kids, you got blue line and you got pink line. They intersect. Did you know if you added them together? Yeah, blah, blah, blah. Okay, well, let's be creative. This green line, bright green. Did you know this green line also intersect? Oh, green makes it hard to see that. Let's go. Oh, we can. We got blue. We got pink. Let's go. It's dark green. So yeah, hey, there's another line that intersects. Yeah, we know. So we're going to add different variations of those 2 lines together. Does this new line right here, that simplified one, does that help you at all? No. What do you want me to do to, you know, for that to help you? I said, well, make it horizontal. And you can obviously talk to him about the vertical thing later, because that's super helpful. Okay, so let's play with these sliders. How will I know when it's a horizontal line? Well, when that's just f of x equals some number. Okay, so, okay, make it okay, that's kind of close. And what I'm struggling with here is on this blue line, I'm not using integers here. Okay. I wonder if I can adjust the increments on this guy. Let's go increments at 0.01. Let's try that. Trying to get that green line horizontal. Okay. It's actually not a bad task, right? Just have keep checking different combinations. Let's see if we can do it there. Okay, we'll adjust this slider. About there. Okay. Let's move this one all the way over here. Move this one to 100. Almost. Pretty close, not quite. Getting close. Oh, went past it. Got this one. So anyway, you can adjust the scale on here. Oh, that's so close. I think you get the idea. I'd probably just adjust the scale. Not that you want to watch a 40-minute video. Let's go slope of line 1, increments by 1. Go y-intercept line 1, increments by 1. Slope line 2, increments of 1. Y-intercept line 2, increments of 1. I mean, not a bad lesson, right? For some lines, it can be really hard to figure out what the combination is. So we're just redefining that blue and the pink line, right? Okay. So I got two new lines, blue and pink. I don't want that blue line to be horizontal, though. There we go. Okay. So now you try to make that green line horizontal. Try to do it. Right there. Wow. Negative 77/30ths. Not very pretty. Y-intercept of line 2. Look, it's still a decimal. That's fine, though. We'll make it a whole number. Okay. Right there. Negative 5/3. Wow, what does that mean? Well, I know the y-coordinate where that pink and blue intersected. You just got to multiply line 1 by -4, line 2 by -2. So maybe, well, is there another combination that might work? So just an idea of how you could use GeoGebra. Sorry, it's kind of a rough video. I didn't want to go back and edit it though, but there you go.